Welcome back, dear students. Today we are continuing with the previous topic, that is the application of the normal probability curve. In previous lecture we have discussed two applications of the normal probability curve. We are going to discuss a few here also. Next application is to determine the number of the cases within a given limit or given score. In net examinations we have the questions like this. In a normal distribution, the mean is 60 and the SD is 6. We have to find out how many cases lie between the score 50 and 70 when the number of the cases, total number of the cases is 300. First of all, to find out the number of the cases lying between the two limits score, this is the RAS score, we have to change the RAS score into the standard score, and after that we have to find the percentage of the cases lying between these two standard scores, and then we can find out the number of the cases out of 300 which lie between these two scores. We have here the limits 50 and 70. First of all, we change 50, the RAS score, into the standard score. We have the mean given 60, we have the standard deviation given 6. I have already told you how to change the RAS score into the standard score by using the z-score formula or the standard score formula. By applying these in this standard score formula, we get that the standard score of RAS score 50 is minus 1.6. This is minus 1.6. We have another RAS score, that is the 70. The mean is same 60 and the SD is same the 6. Applying this in the formula, we can get the z-score of the 70. This is the z-score of the 70, 1.6 SD. This is the positive 1.6 SD. We have to find out how many cases lie between the score 50 and 70, and we have changed both the scores into the standard scores. Now we will make the normal probability curve. In the normal probability curve, you already know how much percentage of the cases lie between the different standard deviations, like from mean to 1 SD or from 1 SD to 2 SD. And now we have to find the number of the cases between minus 1.6 SD and plus 1.6 SD. Here the number of the cases between the minus 1.6 SD and the plus 1.6 SD, we know that the percentage of the cases that lie between minus 1 SD to plus 1 SD is 68.26%, and we have to find out the percentage of the cases that lie between plus minus 1 SD to plus minus 1.6 SD. You know that between minus 1 and minus 2 SD, the middle point of this will be 1.5, and 1 point from the middle point there will be 1.6. This will be 1.6 position, and from this side this will be 1.6 position, and this is minus 1.6 position, and this is plus 1.6 position. We have to find the cases, the percentage of the cases first between these two limits. Now that from minus 1 to minus 1.6 or from plus 1 to plus 1.6, the distance between these two limits is 8.15%. From this to this and from this to this, it is 8.15%. We have to find the percentage of the cases that lie between minus 1.6 and plus 1.6 standard deviations. That will be percentage of the cases that lie between minus and plus SD, and the percentage of the cases that lie from minus 1 to minus 1.6 SD and plus 1 to plus 1.6 SD. We have to find finally from this point to this point. Here plus minus 1 SD, how much percentage of the cases fall? That's 68.26%. So we write here 68.26%, and how much of the percentage of the cases fall between minus 1 to minus 1.6 SD? 8.5, and from plus 1 to plus 1.6 SD, that's also the 8.5. By adding all of these, we can get the percentage of the cases between 1.5 and between minus 1.6 to 1.6 SD. That will be equal to 84.56. This means the percentage of the cases that lie between minus 1.6 to plus 1.6 SD, the cases percentage of the cases in between these two limits is 8.54%. But we have not to find the percentage. But the question asks us that how many cases out of the total cases, that is the 300. So here the number of the cases is 300, and we have to find the number of the cases that lie between these two limits. That means the number of the cases will be equal to 84.56%. that is this is the percentage out of 100, and we have to find out of 300 how many cases lie. We can say that if we have 100 cases, that then between these two limits there will be the cases 84.56. Now out of 300 how much number of the cases will be there? So 84.56 divided by 100, it's the 100 of this percentage, because percentage is out of the 100 always, multiplied by 300. By solving this, we find that the number of the cases that lie between RAS score 50 and the RAS score 70 is 253.68. That will be rounded off to 254 cases. That means out of 300 how many cases lie from 1.6 minus 1.6 to plus 1.6 SD, that is 254. These questions come in the NET examinations like this. Another application is to determine the percentage of the cases that lie below or above some score. We have the score given from there, and we have to find out how many cases either the question asks us lie below that score or above that score. Let us have an example. In a normal distribution with mean 52 and the standard deviation 5, what percentage of the cases lie above the score 55? Next, what percentage of the cases lie below the score 55? And here it is the RAS score. First of all, we have to convert this RAS score into the standard score. How we convert this RAS score into the standard score? By applying all these given observations into the z-score formula, we will get the standard score of 55 is 0.6 SD. Now we have to find what percentage of the cases lie above this 0.6 SD. For that, we will frame the normal probability curve. We have to find number of the cases above this score. The percentage of the cases, this area covers approximately 100% of the cases, but not equal to 100% of the cases. Approximately it's 100% of the cases. Now from mean to the right hand side, where the positive cases lie, the number of the cases will be equal to the 50%, and from mean hand side where the negative cases lie, the number of the cases will be 50%. As I have written here, that from mean to plus minus 3 SD, the number of the cases is approximately equal to 50%. Now we have to find number of the cases above this score. For that, we will find what will be the percentage of the cases between mean and 1 SD. Cases between mean and plus 1 SD is equal to 34.13% of the cases. In this distance there are 34.13% of the cases. Now you know that in between mean and 1 SD, the middle point will be 0.5 SD, and from middle point to 1 point more than that, that will be 0.6 SD. Okay, and we have to find the cases that lie above this. Above this means the cases that lie on the positive side of this curve. You know that when we divide this portion into the half of the cases may be 17.06 case from mean to 0.5 and from 0.5 to 1 SD. But we have to find mean to 0.6. Here is the number of the cases that lie between mean to 0.6 SD, that is 20.48 cases may lie from mean to 0.6 standard deviation from the positive side. But we have to find the cases above this point. That means from the right hand side, how many cases are there. You know that the percentage of the cases from mean of the left hand side is the approximately 50%, and from this position from mean to 0.6 SD it is 20.48%. Now subtracting the 50% cases that lie on the right hand side by this portion, we will get this portion. By subtracting 50% by 20.48%, we get 29.52% of the cases lie above the 0.6 SD. That means from this point to this point there are 29.52 cases. Now what will be the score below 50? Here the mean is same and also the last score is same, standard deviation is same, and the standard score will be same. This is the standard score of 55, that is 0.6, but this time we have to find below this point. So from below this point, that means from this point to this side, we have to find the number of the cases from 0.6 SD to the left hand side of the curve. You know, from mean to 0.6 SD, the percentage of the cases came out to be 20.48%, and you know from mean to the left hand side there is 50% of the cases approximately. So we add up this portion and this portion, that will be equal to 70.48. That means the percentage of the cases that lie below the 55, below the score 55 or the below the standard score 0.6 is 70.48%, and above the 0.6 is 29.52%. That means from here to this side it is 29.52%, and from here to left hand side it is 70.48%. I hope you have understood this. Now here is an exercise for you people to do. In a normal distribution where the mean is 80 and the standard deviation is 10 and the number is given there 500, you have to find out the number of the cases that lie between the score 50 and 70, that lie between the score 60 and 90, and that lie between the score 45 and 85. Because here first of all you have to change this raw score into the standard score. Then you have to find the percentage of the cases that lie between these two scores, and after that you will get how much percentage of the cases out of 500 lie between these two scores. Okay, next question you have here. In a normal distribution where the mean is 80 and the standard deviation is 10, you have to find out the percentage of the cases that lie below the following scores: 50, 90, 45 and 85. And next question you have the normal distribution curve where the mean is 80 and standard deviation is 10. You have to find the percentage of the cases that lie above the following scores: 55, 89, 75 and 95. That's all for today. I will be back with a new video lecture. Till then, stay safe, stay healthy and stay motivated. Stay tuned to the channel. God bless.